Okay, welcome to the lecture series on 8051 microcontroller. Today we will be discussing about the instruction sets in 8051. So basically, all the instructions of 8051 can be categorized into these uh, into these categories. So the first one is your data transfer instructions. Instructions like the move C, move X, push, pop, XCH and XCHD instruction comes under the data transfer instruction set. And this basically pertains to transferring data from one memory location to another. Then comes the arithmetic instruction set. It includes the add C, sub B, INC, DEC, MUL, DIV, and DAA. These are the various instructions available in the arithmetic instruction set. We will be discussing about each one of them in a short while from now. Then we have the logical instructions of 8051, the ANL, ORL, XRL, CRL, CPL, RL. These are basically the logical instructions. ANL basically stand for logical and logical or is there, logical XOR, clear. This is complement, rotate rotate left with carry, rotate right with carry, then swap. So these are the instructions of uh, which comes under the logical instruction set. Then we have the boolean or bit manipulation instructions like your clear, set B, move JC. So move is here also, move is here also. Okay, so there's a difference between these two moves. This is a bit instruction, okay, while this is a byte instruction. We will discuss what is bit and byte instruction again in a short while from now. Then we have this JC and JNC, jump if carry, jump if not carry, jump if bit is 0, jump if bit is not 0. So then these instruction. Okay, so again you could see here, sorry, ANL, logical and is here, and uh, logical or is there, CPL is there, complement. So these are again bit instructions. Okay, then we have the uh, sorry, we have the program branching instructions. The program branching instructions include the LJMP, okay, and uh, long jump. This is long jump. Then AJMP, short jump is there, jump if 0, jump if not 0. So these are the various no operation, L call, long call, absolute call. So these are some of the instructions in the program branching. So we will be discussing all these instructions one by one and see how we can use them in our program. Okay. So in this particular lecture, I will be concentrating on these two groups, the data transfer group and the arithmetic group. And then I will take up the other group in other video. Okay. So let's move. Before getting into the various instructions, let us see what are the opcodes that are associated with the instruction of 8051. Okay, so basically each of the instruction of 8051 has got an opcode. So instruction could be of 1 byte or 2 byte or 3 byte, or it may be even 4 bytes, but the opcode that is associated with the particular instruction is always of 1 byte, that is 8 bits. So you could see here, this is basically a table which through which you can find out what is the opcode associated with a particular instruction. Take for example the case of add instruction. So you could see adds appearing all the way from this point to this point. So this add, the first add, is basically associated with this number 20 and 04. So the opcode for this add will basically be 24H. Okay, similarly, the opcode for this add will be, since this is 20 and this is 205, so 25H and so on. Okay, so it becomes more clear if we see the next slide. So why we are having different opcode for same add? So you see, add can be used in different ways. So there are different uh, what we call the uh, the modes of instructions. Okay, addressing modes. So there could be a immediate data transfer with the help of this add instruction, or there could be uh, indirect addressing, or there could be register addressing, or there could be direct addressing associated with the add instruction. So each of them is having a different opcode. Okay, please remember that this is the code which basically resides in the memory of the 8051, the ROM of the 8051. The program, the assembly language you are what which you are writing is not saved like that. It is first converted into the hex form, and it is basically the instruction is associated with the opcode, then data is again is having a hex value. So those things are stored in the memory of 8051. I hope it's clear now. So let's start with the data transfer instruction set. Okay, and we have not many. We have got move c, move x, push pop xch and xchd instruction in the data transfer set. So let's start with the move. So move again can be used in multiple ways. Move instruction is basically used to copy the data from a memory location to a particular register, or from the register to a particular memory location, and that could be in any of the five discussed addressing mode, or either it could be immediate addressing like this one. So this is basically the syntax of the immediate addressing mode. Move a comma hash followed by the data. Then this is your register addressing mode, direct addressing mode, indirect addressing mode. Okay, and then this again is your immediate addressing mode. Okay, so we will try to see some instructions. Okay, so that it becomes more clear. uh, let us take an example of immediate addressing mode. So we take move uh, a comma hash 25h. So this is an instruction in which the value 25 is copied to the register A. A is the accumulator. Okay, so this hash sign basically indicates that this value 25 is a data and not the memory address. Okay, so after the execution of this instruction, A will be having a value of 25h. Fine. Now take another example. Move A comma say R0, and suppose that R0 is having a value of say 35h. So after the execution of this instruction, the value of R0 will be transferred to A. So A will be having 35h after the execution of this instruction. Take another example. Move A comma say 20h. Now this is an example of direct addressing. Okay, so 20h is a memory location now, it is not a data. And let us assume that 20h h is having a value of say 52h. Okay, so after this instruction, the content of 20, which is 52, this will be transferred to a. So a will now be having a value equals to 52h after the execution of this particular instruction. Take another example. Move a comma at the rate r naught. Okay, so r naught was having the value 35, and say 35, the memory location 35 is having a value equals to say 45h. So after this instruction, this is an indirect addressing mode. So in r naught we have got 35, and in memory location 35 we have got value 45. So after this instruction, a will be having the value 45. Okay, so basically this is acting as a pointer to the memory location of the number stored in r0. Okay, so these are the various forms of move instruction. Let us now see the move c instruction. Move c. Okay, so what is move c instruction? Move c instruction is basically used to transfer uh, data from ROM, from ROM, either internal or external. Okay, so uh, now one thing to note here is that uh, although code is saved in ROM, but sometimes some essential data are also saved in ROM. Okay, so to access those data we need to have some instruction. Okay, I had given you an example of traffic lighting system wherein the values of 1 2 3 4 that appears on the LCD need to have some code, and that has to be stored somewhere, and that is stored in ROM, and it is accessed with the help of this move c instruction. Okay, so move c instruction, uh, how we can use it? It normally is used like this: move c a comma at the rate a plus dptr. So dptr is the data pointer, and it is a 16-bit register. Basically it consists of two 8-bit registers, so dph and dpl. Okay, so this value, say for example a is equals to 5h, and dptr is equals to 3000h. So if you add these two, how much you get? 3005h. Okay, so this instruction will result in copying the content of 3005h. Say for example this memory location is having a value of say 20h. Okay, so this is a memory location, and this is the content of the memory location. 20h is the data that is stored in 3005h. Okay, so this will be copied to a. Similarly we can use uh, the, uh, the next instruction is move x. Okay, so next instruction is move x. One more thing I would like to point out with the move c instruction, that we can use it in this form also. We can use at the rate a plus the program counter. So program counter also, we know that it has the information about the address of the code being executed, and actually the next instruction of the code that has to be executed by the program. So we can use it in this form also. So now let's see move x. So move x instruction is used to uh, to again transfer data from external RAM. For internal RAM we use move. For external RAM, we use move X. Okay, because you know that external RAM